Hi, Badley. Hi, Jackie.
How are you?
Yeah, I'm doing great.
That's great.
Yeah, nice to meet you. Hey,
Yeah.
Uh,
Ah, there's Shubham and Himanshu and Morgan. Hello.
hello.
Good morning.
Morning. Yeah. Right. So yeah, welcome. So where do we want to start? I guess updates. Himanshu, would you like to start?
Yeah, yeah, I'd like to start. Yeah, so like I've been working at Browser Stack for around a month now. It's been great. So actually my timings are from 4 to 1 or 5 to 2, like 5 p.m. to 2 a.m. So that is why I was not able to join a lot of meets in this coming year. But I've been looking into the recordings to see the updates as well for the projects, and it's been going good. Like even a GSoC of student of ours, like a contributor of ours, also was in hospital, but they are also doing great now. So it's good. Uh, yeah,
Okay. Yeah, that's great.
yep. Yeah, so today my it was from 12 to 9, like my shift today.
Right.
So which is why I was able to join in. Yeah, it's happy to be here.
Well, that's good. Well, thanks for joining. Yeah.
Yeah.
Hello, Pakhi. So, Shubham or Pakhi, who wants to go first?
I have a quick presentation, so I can go ahead.
Okay.
Over the last week, I was, as I mentioned in my previous meet, I will be doing some graphical representations. We can measure some parameters like, yeah, so basically, as I mentioned in my proposal, I created a portal kind of thing where, people, or the users can play around with, different parameters, number of contributors, issues, and maintainers, the steps per second, and everything. Plus, I have generated certain graphs. We have the Earth issues, the Mars issues. So basically, after every step, how many issues do we have that are resolved, and then we have the accepted PRs. So and I have the average efficiency after so many steps, and then I also have the average resolution time and average. So average resolution time is basically the time difference between when the issue was created and when it was marked for a review, or when the PR was raised for that particular issue. And average review time is when the issue was when the PR was raised and when it was reviewed by the maintainer. So I'll just run this once again and show it to you, the simulation. So here the simulation is working the agents, the economists and the maintainers are moving around, trying to find the issue agents. And here there are it is generating some real-time graphs based on these parameters. So what we can do is we can compare the rate at which the issues are being the PRs are being raised, and this black graph shows the rate at which the PRs are being accepted. Then we have the real-time graph generation of the average code efficiency. So it is somewhere around 60 point something. And then we can also compare the average time, resolution time, and the average review time. So what the general pattern I've seen over here is the average resolution time is way more than the average review time. So we can draw out many conclusions out of these parameters. So for now, there's this much. If anyone has any questions, or if they want to, add on to any more parameters that I can generate over here.
Yeah, that looks great. So let's go up to the top.
Yeah.
So this is, of course, the multi-agent
Yes.
reinforcement learning.
No, the RL part is not implemented yet.
No,
The
okay.
AVM part is done. So basically, this is working completely randomly now.
Oh,
So
okay.
to make it more realistic, we can implement RL into it. We can introduce a reward system so that we can make it more realistic, basically, so that agents actually target the issue agents. Right now, they're moving randomly around the grids.
All right. So this is And so this grid has agents moving randomly around a point. And then there's some stationary points. So what are those?
The issue agents are stationary points. I didn't, I meant the issue agents were meant to be stationary from the first place. Only the issue contributor agents and the maintainer agents are moving around the grid trying to find the issue agents. So the issue agents are stationary.
All right. And so the mobile agents are, what do you call those?
The contributor agents and the maintainer agents. So the contributor agents are again classified into three. We have the beginners, intermediates, and advanced.
All right. I'm just trying to go back over this to remind myself. So that's what's moving around. Then, it does look kind of like it's moving around randomly, but yeah, you would then add in the reinforcement learning mechanism to refine this. All right, so why don't you go down to the next set of graphs? So this is Earth issues, Mars issues, Moon issues, and then accepted PRs. So the Earth issues are actually lower than the Moon issues, which is interesting.
So Earth issues are the easier issues. Mars issues are the the intermediate kind of issues, and the Moon issues are the ones that are sort of difficult.
Okay.
So basically, right now, when we are introducing all the issue agents into the grid, they are being randomly classified into these things, and then later we can give different rewards for solving each kind of issue.
Okay. And so, but then the accepted PRs go from sort of lagging the issue creation to
that is because the maintainers and the contributors and everything over here is like same number. So one we can draw certain conclusions from these. That is that one of the conclusions could be that we have more maintainers than we actually require, seeing the rate of PRs being accepted per step, and the issues are actually lagging. Solving the issues are actually lagging behind. So one conclusion that could be drawn out is we need more contributors in the repository or the open source project. So these are certain conclusions that we can draw out from these graphs based on the results.
Yeah. Well, yeah. If you add more, if you add more contributors, actually, the accepted pull requests would probably lag longer because it would be like catching up to whatever's being worked on. But then probably like exceed that, maybe even more so later. So it'd be interesting to play around with the numbers like of agents to see what that looks like.
Further, I have the average code efficiency. Basically, it's the while all the contributors are raising PRs, right now they are being assigned a random threshold, random value for their code efficiency. So of all the issues, the PRs that are being raised, we are finding an average efficiency, and this is the average efficiency per step.
Okay.
So it is somewhere around a little more than 70.
So how do you define code efficiency? How does that get measured?
We don't define. It's like whenever the PR is being raised, the PR is assigned some random value between 40 to 70, and the entire thing is working on assumption in this agent-based model. So the PR is being raised and it is being assigned a random value between 40 to 70, and that is the code efficiency.
Okay. Let's see. So it basically starts at 40 and then goes up to 70. Okay.
Or maybe I think I changed the numbers. I can't recall. Maybe I changed the numbers. That's why the average is going more than 70, I guess. Right?
Yeah. So I mean, why do you define it that way? What do you call it efficiency?
Just so that we can have when the maintainer, because what happens is if the maintainer is reviewing some PR, right? They have certain criteria whether the PR is the code in the PR is good enough to be merged with the main branch or not. So this is kind of a filter or something like that. Okay, only if the code, it's like a maybe it's a numerical estimation of how good your code is and whether it is good enough to be merged with the main branch or not. It's just a numerical estimation of that.
Yeah.
So if it's better than a certain value, then it's good enough to be merged. If not, the issue is raised again, and you have to raise a PR again for that particular issue.
All right. That's good. Next graph is
we have average resolution time and the average review time.
So the resolution time is starts at 0. Review time. So the review time should be, I guess, maybe
basically it should be as less as possible because we want the issues to be solved as soon as possible, and also the PR should be reviewed as soon as possible. So I think the average review time is pretty good, but the resolution time, basically the contributors are taking time to solve, raise PRs and solve issues. So this is again another proof that we need more contributors in the space.
Yeah. Well, the review time, would that be like how long it takes the maintainer to accept
yes,
it? Or? Okay.
Accept a PR.
All right. So that should be less than resolution time, which would be
basically both should be as less as possible because we want the work to be done like soon enough or fast enough, right?
Yeah. So that maybe trend downward over time, or
okay. It should be turned. As in, how do I explain that? We want so average resolution time is basically the time between when the issue was created and when the issue was resolved and a PR was raised for it. So we want that time to be as less as possible, right?
Yeah.
So that is what I was trying to explain. This value should be as less as possible. Actually, both the values, average resolution time and average review time.
Okay.
Did I make it like? Do I explain again? Or,
oh yeah, no, I get it. Yeah, it's fine. Yeah. Well, again, if once you get the reinforcement learning component in, you can actually look at the trends, or you can actually compare the random with the reinforcement learning, which would be a nice demonstration of the sort of the efficacy of your environment. Like depending on the policies you have available to you, what is the distinction from like random activity? And so that would okay. That's it. That's all your graphs.
Yeah.
Okay.
Yeah, that's all. I actually wanted any suggestions if I could have any more graphs or any more parameters that I could add into this.
Yeah. So I mean, this is good. You would have. I think that's good to start with. Just those parameters. You don't want to have too many because you're getting kind of like, you just have too much too much going on.
Yeah.
So and then you want to optimize each measure as you go along. So if it looks like it needs to be optimized, you have to kind of figure out how to sort of what are the benchmarks for these. So I mean, I guess it would be like one benchmark would be kind of like maybe setting something constant like the number of contributors running the random case, running the reinforcement learning case, and and then looking at the difference, and then maybe trying another number of contributors, comparing those. You might try like like Sarrah's created some tasks that are very specific for large language models. So like she has in the repository now, she has some of those. You might create some like tasks that are very simple and say we're going to try this out and see if this works. I don't know how you have the task set up, like how that works, but that's something to at least make sure that you can have a way to say these are the tasks. Maybe we could have a benchmark, specific task benchmark, and see how these parameters behave, and just to get a sense of how good these measures are. Yeah. But I think, yeah, this is good. This has a nice set here of things that we can look at: review time, resolution, efficiency. The efficiency, of course, is like kind of qualitative. I mean, you could do like you could actually take like the code length or something, but that's kind of not as people usually look at the code length of something, but that doesn't really tell you
Yeah.
a whole lot. So yeah, I guess this is good. And again, I don't know if you have like maybe an output showing the number of contributors, or I guess that's probably not.
Yeah.
Yeah.
So basically, the number of contributors is we're giving the input over here, right? We can like play around with the value as well. We
Yeah.
can change it if you like. So if I just reset and I have like 13 issues and like 27 maintainers, like that is pretty much possible.
Okay.
Yeah. So we can play around with the number of agents in the simulation.
Yeah.
Yeah.
Yeah, that's good.
Also, I'll look into the tasks and what you were saying something about the tasks and everything.
Yeah, just like having maybe a more structured task as a benchmark. So you say like, this is like we want to do this. I don't know, create a prototype. I don't know, and then like the very specific steps, like drawing or sketching out something, or things that can be done very simply. You can get a set, like you'd say, given this set of tasks, what does the stuff look like? I don't know how that would work in terms of reinforcement learning. Maybe like, yeah, but that's you might talk to Sarrah about that actually.
Sure. Okay. I can actually, even if Himanshu has any suggestions, because he worked on this previously.
Yeah, I don't know, Himanshu, if you have any comments.
Great going until now. I think you should not add any more metrics before getting into the RL part of it.
Okay.
I can look into your code. Is it uploaded anywhere?
No, not yet. Maybe I'll push it tonight.
Yeah, okay. You can push it and I'll have a look at it.
Sure.
Then we can connect.
Sure. Okay.
Yeah, that's great. Thank you.
Thank you so much.
Any other comments or questions? Okay. Well, thank you, Shubham. That's very good work. Look forward to seeing. Yeah, if you want to push things, that'd be great. Yeah. Okay. Yeah. So next up is hello, Sarrah. Pakhi, would you like to present, or do you have an update? Or
yeah, hi. Hello, everyone. So I do have an update since my last one. Just share my screen.
Okay.
Also, I was going to push the code to the repository last week, but I ran into some environment issues. Like it's working fine in the testing repository that I created, but for some reason I'm having some environment issues in the DevoGraph repository. So I just left it for like time being while I was fixing the things in the framework. So I've actually fixed like most of the things. So I'll just go over it. So in the last week's update, the daughter cells were not getting created properly. Like I had some logic, but it was not like very accurate as to how the worm will grow. And I also had to like make the edge dictionary. So this is like a random initial graph of like 10 nodes, and then I'll just show this. Yeah, so we can see like it was like 0 to 9 nodes, but then it now generates like a 10th node. So it is actually adding only one because it's like removing one parent and adding two daughter cells. So it's like adding two, removing one. So in all, like only one node is getting added. And these numbers right now are like the index numbers, like for the nodes in the graph. So they will be like, once I train it on the data set, they will be like replaced with the cell names. And for like the cells, I will like, for every node, I'm planning to like give vector embeddings for the positions of the cells, based on which we can have like the edge weights as well. And like based on those weights, we can decide if we want to have like an edge between two separate nodes. So like now only like for testing it with the data set is left. So I just like fixed a couple of functions that were required for like generating the graph, like growing the graph basically.
So how does it grow the graph? Go back up to the where you have the for loop. Just curious.
All right, I'll just explain the entire workflow.
Okay.
So yeah. Yeah, so like this is like a random initial graph, and like this graph NCA stands for Neural Cellular Automata. So like this is coming from this class. Yeah. So in this class, we like I've created several functions. Like this two data will just get like the data from the like the graph and like convert it to like tensor data sort of, and like it will separate the edges and the nodes and all. This grow function is the one which is like called initially, like in the notebook. Yeah, so like it's calling the NCA.go. This for loop is running only for like the number of nodes in the graph, so it's like iterating over all nodes to like see where it has to add like the daughter cell. So this function, I'll go through that as well. So it's like taking parameters like the graph, like the previous graph and the parent index and all, and then it will actually it's like a small network called the split network, which will like which is basically created to split it into like the daughter cells. And then these daughter cells are like two separate, you can consider like matrices, because they have their own like embeddings and data and all that. So that's why this have to like first separate them and then combine them, kind of, was throwing error otherwise. And then this add daughter cell, it is actually in this file. Yeah, so this is adding like the daughter cells to the graph.
Are you showing a different file?
Yeah, this is like the graph.py. Earlier I was in the graph NCA. Is the share lagging?
I can see
Yeah,
it.
your screen share is still showing graphics here.
Oh, 1 second.
Okay.
Sorry, the weather is pretty bad over here. The Wi-Fi is a bit unstable. Is it fine now?
It's graph.py. Yeah.
So here it's adding like the daughter cells and removing like the parent nodes. So this is like a very simple logic, like divided it to left and right nodes, remove the parent index from the right array, and then like add it with the new nodes, like the daughter cells. So yeah, and then this is like the edges function, which is like removing the edges for the parent index, because like it's no longer there, it has divided into the daughter cells, and creating new edges for the daughter cell. This edge function I still need to test, because I don't have like the coordinates right now, because it will totally depend on the coordinates according to like the logic I'm going by. So this may or may not be correct. I have to test it with the data set. So yeah, that was pretty much it. And then yeah, this sort of graph is like, this is like the growing graph that is getting generated right now.
Okay. So it's just generating this like from just randomly, or
yeah, like right now it is random because I like didn't have the data, like I didn't put the data set right now. I was just fixing like their framework, like in their repository everything was random, but for our like work we have some things predefined, right? Like this certain cell will split into these two daughter cells, which will be like in the embeddings and all, like in the config file and all. So we're getting all that from there. So for that I had to like change a few things here and there. So I think it should work now. I think by Monday we'll be able to like test it with the data set. In the Devo graph, like there's this geometric library. For some reason it's not working, so I just left it for time being. I'll first test it with the data set and then like push it to the repository. I hope that is okay.
yeah, it's fine.
Yeah, that's
This graph, it looks like it's kind of generate. Is there any significance to the position where the cells are, or is it just kind of like generating random?
Yeah, like once I give the coordinates, so what I had thought of it as like it would, based on the coordinates, like a cell would divide in like a certain area, right, and into the daughter cells, and they will also be like nearby. So right now, also you can see it's like right now it's like moving around randomly, but that one I'm thinking would be more stable compared to this. Like the nodes won't scatter everywhere, like it would like grow in a sort of a pattern. So
yeah,
I'll update on that.
Is there a temporal aspect to the graph that you're creating?
I'm sorry, I didn't get you.
So right now, like for a particular organisms, the cells change across time, right?
Yeah.
Yeah. So this is like for a future case, but you might have to think about it as well. Right now, what you're doing is perfectly fine. You can move on to integrating it with our graph as well, but just a thought.
Yeah, like actually the data set that I created from like the CSV file, like the nodes and the edges, for that I used like the graph was growing, like it was iterating over time only. So like at like first time instance, like I think it is the P0th cell, it's called, that was dividing. So like yeah, it will divide based on the time actually.
okay, yeah. That's kind of smushed together, like because when you have a division event, that's time, and so every time the graph grows in this case, it's going to be temporal. So every growth event is going to be something happening in time, and then but it's also rooted in space. And I don't know how it deals with space explicitly. Like if it's growing at like obviously it's maybe going to coordinate positions, but yeah, I mean that's something. It's not going to be like if you had a graph that was sort of spatiotemporal, like a social graph with people.
Mm-hmm.
It would be a little bit different because there's certain rules that we have to follow for the temporal part, where it has to divide into two daughter cells and then two daughter cells, and so that's it's going to be a little bit. I'm curious as to how they treat like graph growth in this package versus like kind of how a lineage tree unfolds. And I mean, I'm just making sure that it's like consistent or compatible with that. I guess I guess we'll see like when you run the whole thing. But
yep.
Okay, yeah, that's great. No, that's good. And please, push what you have when you feel like it's ready, and we'll be okay.
Yeah.
Yeah.
Definitely. Thank you.
Right. Well, thank you. Any other questions for Pakhi? All right. So, Sarrah, you're up next. And actually, Sarrah had a comment here in the chat. This was for Shubham. The moving graphics and everything looks great. Did you make it all from scratch or use a library? This is for the agent-based model and the graphs. Asking since it's something I need to implement as well. I'm currently using Matplotlib and implementing from scratch. So Shubham, did you have? Okay. Shubham says, no, we have a data collector module and chart module within Mesa, which is the agent-based modeling package in Python that can be used for generating graphs. So yeah, that's specific to Mesa. So I don't know what you, I don't know if you can, I don't know what it's actually using.
I had looked into Mesa, like I think some time ago. I don't think it will support the kind of model I'm building, but I'll still try to look into it. But
Okay.
yeah, thanks, Shubham. Yeah, so basically, last time, like as I said, I was working on the metrics and the graphs, and I had some to-dos, and I was trying to get them all done one by one. So last week, I had basically fixed a lot of like small issues and started actually focusing on the metrics. And I had gotten the contributor experience metric done last time, but I wasn't able to get it into a graph properly. I was facing some errors. So I've gotten that done. Basically, this is like a graph that kind of forms after the simulation, and it forms at each time step as well. So you can see the graph progressing. It's very slow though. I mean, the graph isn't slow. The process that each time step takes in the background is slow. Eventually, what I can do is kind of store everything that is happening in the backend in logs form, and kind of run the actual graphical simulation from those logs. Like that is the last plan. Basically, like that will help to actually see how this graph is created in real time. But basically, this is like a basic like time step versus contributor experience graph, and at every time step there is one contributor who successfully submits a pull request, and their experience goes up in that time step. So first it was contributor 2 in the first time step, and then it was contributor 4 in the next time step. So this is one thing that I did this week. Another thing that I did is the code quality metric. So that is one of these simulation metrics. Like it's a metric for the entire simulation. It's not restrictive to one contributor or one maintainer. So basically, so the code quality metric is judged on basically, so when whichever contributor in the simulation pushes their pull request, if their pull request gets approved, then there is an LLM that is told to give a review on that pull request. Like the maintainer also obviously gives a review, and but there is one that is specifically for code quality that I've told them to generate the review. So this is like, for example, review. It includes some suggestions. It includes some things that could be done better. And then based on this code quality review, the actual code quality is, there's another LLM that is queried to give the actual code quality from 1, which is an integer from 1 to 5, and that is passed, and that becomes the code quality for that issue. Now the way I've configured it is for the simulation, like at every time step, more and more issues will keep getting submitted. So the code quality that is there of the simulation as a whole will be an average code quality. So even though this contributor got a code quality of 4, it merged with the existing code quality and the existing number of issues that had been already merged. And with that average, it basically became 3, like the code quality of the entire simulation of the entire repository became 3. So this is a metric I add. And then the next thing I'm trying to do is basically the next thing we need is more issues. Like right now I have my toy repository and I have 2 issues within it, which gives me 2 time steps worth of charts. But to actually simulate it, we need much more, and we need the issues to be dynamic. Like I wouldn't say dynamic for now, but like I kind of wanted the issues to be created on their own instead of putting hard-coded issues each time. So there is some variation in the simulation as well. So this is another script that I'm working on, like basically the same way that I have contributor and maintainer agents. I have an issue creator agent. This could also be the equivalent of a user agent, basically a user who is very invested in this open source repository and wants to improve it. So uh, like basically creates issues based on the existing code to either improve the code or figure out bugs in the code. So right now, like I'm working on this, basically like these are the kind of issues that it will give. So here there are two things. One, I have to give it the code so that it can create some issues for that code, and the next I have to give it basically I have to give it the existing issues also, because it's possible that it will just keep kind of reiterating the same issue over and over again. So that much I have currently figured out, to basically like whatever issues are there in the issues folder, give to this function, and it then based on that the existing issues and the existing code, it writes an issue. I'm still working on the script. Like basically, this is the kind of output that it has, but I need to parse stuff from this. Like I need to parse the title, parse the description, and parse the example code and kind of save it all into the file in the exact pattern and also into the issues object that I have. So like that is, I'm still working on, like currently I've just commented that part. It was giving some errors. It's a lot of file handling. So that is the next thing I will do. Once these issues are being able to be like dynamically created, or like created in a loop, not on their own, but I can create the issues within using the existing code whenever I want. Then I'll basically start running my simulation for like more time steps. I'll start from like 10 to 20. Maybe we can go into like more than that also, but because it's LLMs, I'll have to figure out the maximum this. And so code quality is another metric that is done, and once we have these issues, then we'll have like I'll have two main types of metrics, like the motivation ones, which come from personalization and some more. So once this is done, like once these issues are done, I think the next thing I'll start working on in the next week is the personalization part. Basically giving each agent a story. I worked on it a little bit this week also, but it's not fully working code. I have like some ideas and some like research that I've done about how to kind of implement personalization by giving the LLMs only giving them one prompt after the other, like come up with a name for yourself, then come up with a short description of how you are, then come up with a backstory, and then that description affects every decision that they take. So even when they bid, it depends on this kind of backstory that they have, and then there'll be metrics like motivation and engagement that depend on that. So that's like something that I'm still going to work on. Hopefully it should be this week once I'm done with the issues.
Okay. Well, that's good. Thank you for that. I had a question about like the generating issues. I thought that was interesting. So, I mean, like I guess you would have like a way to generate issues kind of from like a template. You just say like, this is supposed to be the title, the description, and then you would just generate stuff. So you could, I mean, I don't know, you might generate nonsense issues. You might generate some very tight issues. So what's the quality control there?
Currently there isn't any. Currently the quality, like it's not quality control in a way, it is a way to prompt. Basically if I just tell an LLM, create an issue, it might create basically anything. So currently my way is this like kind of similar to chain of thought prompting, but not exactly. Basically, I'm giving it these existing issues. So because I give it these existing issues, and I always have at least these two hard-coded issues, and they have this format, and they're also very detailed, it gets some idea of what to do. So which is why, like, because I give it these issues, this that it has created, it's kind of, it makes sense. Quality control could be that I could implement more quality control in a way that I could have another LLM kind of fact check these issues and kind of say whether this issue makes sense or no. The same way the maintainer looks at the contributor's code and approves it, the similar way I could have another LLM that kind of decides to accept the issue or not. But I think before I do that, I think I'll try making a few issues, and also try, so like this issue that it made, adding this back into the existing issues, and then kind of chaining it like that, and generating another one. I'll try that. If after maybe 3 or 4 loops, I feel that it is creating something nonsensical, then I can implement that quality control in a way.
Okay. Himanshu, did you have a comment?
No, good update.
Okay. Yeah, thank you, Sarrah. So yeah, I mean that sounds good. I think just experimenting with how good of a job it does in generating issues would be good, and definitely having a human in the loop to check the issues that are generated would be important, or having like a step where people check the issue before it gets implemented as an issue. But right, go ahead.
Yeah, human in the loop could also be another. It could be a human in the loop or LLM in the loop both. I could try to implement human in the loop also, like by making it optional. Not everyone needs to do it.
Yeah.
But if you want, it could be there that you have to say yes or no. So I could try to do that as well. I'll try to experiment more on the issues part this week.
It's kind of
So
hard
basically validate what the LLM is coming up with, right?
Yeah, to validate. Like my idea was putting another LLM there, and Bradley suggested a human in the loop. So I could try with both of those, but I'll try to, like, first I'll experiment. If it's needed, then I'll definitely try to implement one of these.
And the initial generated issues, are they also created by AI itself, or is there
yeah, the base two, they were created by AI, but not purely AI. Like basically it was me using ChatGPT. So in a way that, like, it was me giving the exact prompt, and it gave me a bunch of issues, and then I selected specific ones, then I reprompted it to make it better, add this, add that, like that.
Okay, yeah.
I did add, these are not like completely written by me, the base ones.
No, I understand. You used AI to help doing AI stuff.
Yeah, I actually, like, even then, basically my main motive was to do that only, to figure out whether it can make good enough issues. So yeah, at that time I do remember it took me some prompting, which is why I was trying to basically recreate the chain prompting that I did. I was trying to recreate it with this, like, one prompt. So this will also need some revisions where I need to, like, tell it exactly what to create, and maybe that should help.
And what LLM are you using currently under the hood?
Llama 3.
8 billion, right? Okay.
Oh, sorry, what? Yeah, the 8 billion.
Yeah. Okay.
Yeah, that's the only one that works on my computer. Mistral also works, but then because I'm using autocode rover only has support for Llama 3. So that's
right.
Now.
Okay, so thank you. That was a good update, Sarrah. I'm looking forward to seeing another push on that soon.
Yeah. I'll propose a question.
Okay. So one word, for the GSoC students, Sarrah and Pakhi, and I don't. This applies to Shubham, but our projects are coming due in a couple weeks. So at the end of this month, I think, is the official end of GSoC. Now, if you want to get an extension, if you need an extension, I have to request it before the evaluation period. So if you think you need more time, please let me know. But this is something where this kind of sneaks up on us every year, where you're kind of working on the project and you're like, okay, that's due. So a couple of tips that I've had from years past. First of all, I wouldn't worry about the degree of completion for the project. I wouldn't request an extension, for example, if you just want to add in some sort of nice to have features. I would just kind of say, okay, what can I accomplish in the next couple weeks? And then when you get to that point, you say, okay, I have maybe 4 weeks. Let me get these things to completion, and then that's the end of what I'm going to submit to Google. I mean, you can still keep working on your project after the end of the coding period, but that's not something that concerns, whatever project gets turned in. So, kind of figure out where you are now in your projects and say, okay, I'm going to finish up these features. I'm going to finish up this work, bring it to some level of completion. And then you remember you have to also have a submission sort of write-up. So what I've had in the past are people have taken their code, and of course, we've both Pakhi and Sarrah both maintained repositories for the project. So, kind of organize your repository, make sure that it's easy to navigate, that, the things are in the places that they should be. And then, write up a README file or, some other mechanism. Sometimes I've had students do like a gist repository for submitting the project. Other times they just submit their GitHub repo. As long as you have like a place where when you submit the project, you can put a link. That link leads to a README file that has instructions about everything in the project. And then that project can be cloned and run by the evaluators at Google. So that's basically what we want. And if I think both of you, it's pretty much a case of here's the project, here's what's there, and I don't know if I don't know how they actually, because the guidelines in the last couple of years have been a little bit looser than they used to be. But I don't know if you need to have an executable, but you do need to have like everything organized. You need to have a README that kind of describes the motivation for the project, what you've done, and then what the files are that are in the repository directories, and how to basically run it, or if it's not runnable right now, how it would be run in the future. So I'm not really sure. I think that's probably sufficient because people they've included projects where you're not actually producing code for the whole thing. But in any case, what I would do in the next couple weeks is just bring the issues that you think are the most sort of the things you can finish up in the next couple weeks to completion. Write up that documentation, make sure that everything is in one place, and then have that link ready to submit to Google at the final submission. So I believe the submissions are around the end of the month, or maybe in the last week of the month. And so we'll talk about that maybe next week in terms of what the due dates are. But just be knowledgeable about the deadlines and about where your project fits into that. Okay, so that's great. So I don't know, Jesse or Morgan, if you had anything you wanted to talk about or any updates.
Yeah, not really. But great to see progress, and yeah. I'm gonna be heading to the Fedora project next week.
Okay.
So yeah, that's kind of the software I'm looking at right now. But no real report. Yeah.
So you're working on the Fedora project, or you're
Yeah, so I want to spin out a new lab. So the Fedora project is Linux distribution, and under Fedora there are labs, and those are kind of science focused software collections, right? So the Neurofedora started as a kind of basically a Fedora version of Neurodebian. So I used Neurodebian, but Oxford and MIT Harvard both, where FreeSurfer and FSL are developed, are big CentOS labs, and the clusters, the compute clusters were CentOS based. So if I wanted to get things upstream of CentOS, then Fedora was the way to go. Neurodebian was not helpful.
Yeah.
Anyway, the computational neuroscience lab has been very successful in Neurofedora, but there are already a good number of neuroimaging tools. I can put a link. Sorry. Just one sec. Yep. Put a link in here. So we have a number of neuroimaging tools, but there's just a few more that just need to be added. So I've just been building a couple of the kind of most downloaded tools from a big neuroimaging site called Nitric. I kind of looked to see what the big downloads were, and yeah. So anyway, they're meeting in Rochester this year.
Okay.
And might also swing by computational cognitive neuroscience.
Oh, that'd be great. Yeah.
Rochester, New York.
Rochester, New York. Yes.
And
Yes.
you're
But
Oh, sorry. Go ahead.
No. Please.
Well, you were going to say something about Rochester, New York, and then you're going to swing by some computational. What? I got caught up.
Yeah, computational cognitive neuroscience is in Boston.
Yeah. Who goes to Boston, really? But yeah.
And my son is also looking at colleges, so I think we're swinging by Syracuse.
Okay. Yeah.
Be up that up in New England for, well, I guess New York's not technically New England. But.
Well, hey, let me know when you're in Boston. I may be at that event also. I don't know, depending on if I can.
Okay, cool. It kind of overlaps, so it's like if you could check out computational. Ooh, there's something popped up, but if you could check that out, that would be awesome.
Next week.
Yeah.
Yeah.
Okay.
Yeah. And of course, the computational 3D workshop is going on right now. Is the other big software project that I've been kind of watching. Yeah. So segment anything 2, the team leader of segment anything 2 is going to be at an event here in the Bay Area next week. Anyway, I'm yeah. It's there's a lot going on at the same time. but really hoping to see, yeah. So they're gonna do. They're talking about doing a hackathon with Sam too, and the team leader is gonna be there. I forget her name right now, but and yeah, it's been tested. It's been trained on a lot of microscopy data. So there's some really nice things. I mentioned Sam in the the Celsius Slack because it's a part of the Braingineers pipeline. They use it for segmenting organoids with this kind of low cost microscope that does some very basic size estimation and things like that.
Yeah.
But yeah, it looks yeah.
So yeah, last year one of our GSoC students used Segment Anything for some of the embryology data that we had, like just taking some microscopy images and yeah, and so you have like the bounding box model where you can just take a bounding box and find things within it, and then also another more conventional segmentation model, text prompt segmentation model, where you can just enter, if you have the images annotated, you can like find things with labels and all sorts of things like that. So it's actually quite a nice set of tools. Yeah, I'd be interested to see what comes out of that area. So we might revisit this for DevoLearn as well. So
gotcha. So it's they're using SAM1, I guess we can call it now. SAM1 and Katerina's most recent bioarchive paper.
Okay.
That's the when did that come out? It was kind of like mid-March or something like that. Anyway, but it's the one that's still bioarchive, hasn't been published yet.
Okay. Yeah.
And and I see when I search with Archive Sanity Preserver, well, in this case Archive Sanity Lite,
yeah.
The search for organoids, you see SAM come up quite a bit in terms of these segmentation of the various ways that imaging data is being used in kind of organoid culture lab automation.
Okay.
But I think it was sorry, I'm trying to remember now where I saw that SAM2. I wouldn't be surprised if it was Bits in Bio. Let me just check that.
All right.
Yeah, Nikili Ravi, or that's it. Yeah. So SAM2 hackathon. Oh, it's tomorrow.
Oh, okay.
Yeah, and the AGI house in San Francisco.
Good.
So maybe I can. AGI house. Yeah. There's a couple AGI houses.
I know. I was joking to some friends about maybe not an Orel house or like a Jopra house, but like the themed housing is sort of interesting. More about that some other time, I guess.
Yeah. They just had they just started a longevity house here.
Yeah, I just applied to one of the longevity, or actually the Foresight Institute, with some longevity stuff.
Okay, sure.
We'll see about
sure.
that.
Well, I assume from all the buzz, or longevity buzz, that ARDD is coming up, which is the big, I would say the big science focused longevity conference. But I forget. Maybe that's in Copenhagen. I'm not sure. Anyway, I'll see. I'll definitely try and hear what happens. Like if I can't make it to the hackathon, I'll see is going that I know.
Great. Yeah.
But yeah, we did we co-hosted the Celsius event with Bits and Bio.
Okay.
That was the group. Yeah. So it's pretty cool. They help. Yeah, definitely give us a lot of visibility. But I know it's 10, so.
I just wanted to mention a few things here in the chat. So Morgan put the Fedora project up. So Neurofedora is like Fedora, but it has like tools for neuroimaging in it. It packaged with it.
So that's how I started it. I should say that I started it with this Fedora contributor named Igor, and it was definitely focused on neuroimaging and neurodebian. Basically a RPM based neurodebian.
Yeah.
But Ankur Sinha has really has led the project since like 2018, and he I think he's in David Silver's lab. So DeepMind, UCL, and they've had a real focus on computational neuroscience tools. So he's done. You can see, and I think he has GSoC students this cycle too. So I think they're focused on NeuroML. So you can see Ankur's updates, via Fedora Planet or via his blog, and what I want to do is put together a nice, basically a lab page for neuroimaging. So finish a couple more tools that would be nice in terms of being widely used, and then just show how everything's already packaged in Fedora, ready to go, and just need to put together kind of like something like just a couple blog posts just showing people how to download data from open human connectome projects to start looking at data and giving them some examples.
Yeah, good. Himanshu, that was the link to segment anything too, and it's a pretty amazing tool. There's MedSam, of course. Yeah, that's something that was used in a prior GSoC. I think we did this like last year where there was a fork of SAM1, or I think maybe a version of MedSam that we used for DevoLearn, and there are different versions of SAM for biological stuff. So there's like a medical imaging version. There's like, of course, they're using it with organoids, and I guess it's very good for like segmenting, because when you're dealing with biological data sets, you're trying to like pick structures out of a lot of background noise. You're sometimes picking arbitrary boundaries. Sometimes the boundaries are very hard to see because you have different focal planes, and it's just kind of hard. It's a hard problem in a lot of ways. And this is nice because you don't have to worry so much about, I guess the performance is pretty good in these kind of cases. So that's definitely something we have a fork of, and maybe we can figure out ways to improve that fork or improve that set of tools using some of the sort of new innovations coming out of Meta. And then Jesse had some, he said he didn't have any updates today, but he might maybe next week give a small professional development talk or remark. So yeah, I look forward to that. And that's something, we talked about this privately a couple days ago, where, we talked about kind of putting together all the professional development thoughts that we've been kind of putting out in this series of meetings. So, I don't know if there's something that, maybe a more substantial effort, for, getting those things together into a collection for people to easily access. So.
There's something that I'm working on longer term. I'd like to basically do that, and people could. I'd be happy to have people like collaborate or join on that too. Like, I know we're over time right now, but I will just make a generic reminder remark. especially when you're dealing with academia or people trying to do projects, a little FaceTime goes a long way, and it can be virtual otherwise. But if you're ever wondering why things are stuck or like there's things going on, I had a situation happen this week where serendipitously I showed up. Well, I sort of facilitated something happening, and indirectly a problem was solved that we didn't really even know could be solved. More about that some other time, but just like there's something to showing up and talking about your projects, and as Bradley often says, sometimes like momentum is more important than progress in certain ways, or just as important, the appearance of progress. And sometimes when you don't have any momentum, the best way to do it is to just engage the person and talk with them, or go to a place where the people doing it might be. So that's my, a gentle reminder and like something to keep in mind whenever you're dealing with stuff. Because in academia and innovation, it gets stuck all the time. So more about that maybe tomorrow. But yeah, good stuff today, and I look forward to all the project management stuff, the things that Morgan meant. Maybe I'll see Morgan next week, and then everything else happening here too. So good to see all that stuff going on.
All right. Thanks for attending. Have a good week. Thank you.
Take care, everybody.
Take care.
Take care. Bye-bye.